Alright, this is Chapter 1, Lesson 7. These are the guided practice questions off page 68. Talking about a couple different concepts here as we go. Number 1 says, the table and graph below show the amount of money Mi-Ling and Daniel save each week. Who saves more each week? First of all, who saves more each week? We're talking about 1 week, so they're asking you to go to a common denominator of 1 week, or what is called a unit rate, right? How much per 1 week? Alright. Problem is this one doesn't start with 1 week, it starts with 2 weeks. Alright, but we know how to go to a unit rate, I hope. Which one makes more sense? Well, they told you what order, how much money each week, right? So they want it in the order of dollars per week. Alright, well if I divide this, 30 divided by 2 is 15. 45 divided by 3 is 15. 60 divided by 4 is 15. That is proportional because they're all exactly the same when I divide them. Alright. Also, what I want to notice is that as the time goes up 1 week, that's plus 1, it's going up 15 each week. Up 15. Do you see that? That's that whole 15 for every one. Alright. That means Mi-Ling is getting $15 per hour. So I'm going to go to Daniel. Daniel, if you look at him, we could write all these as coordinates. Coordinates being an X and a Y. So let me give you 0, 0. Does that help you understand proportional? Should. 1, 10. And by the way, I'm counting these as an airplane. I'm going horizontal axis, then vertical axis, right? So 2, 20. 3, 30. So on and so forth. I'm not going to give you all those, but if I divide them, you might notice that you try to do 0 divided by 0. Well, guess what? We can't divide by 0, so that one's impossible, but let's try the rest of them. 10 divided by 1 is 10, and notice I'm still going dollars divided by weeks, right? Dollars divided by weeks. 20 divided by 2 is 10. 30 divided by 3 is 10. Do you see that? That is that unit rate, $10 for every one. As the weeks goes up by 1, the savings go up by not 1, but 10. Okay, so that's, once again, that's what we call that constant rate of change. 10 for every one, 10 for every one, 10 for every one. That's $10 for every 1 week, while Mi-Ling was 15 for every one, 15 for every one, $15 for every 1 week. Alright, so now we've got down to a unit rate. We can tell, obviously, that Mi-Ling is getting $5 more a week, so Mi-Ling is saving more each week. Alright, so number 2. Refer to the graph in exercise 1, so we're going to be looking back at the graph. Explain what the points 0, 0, and 1, 10 mean. Well, first of all, we have to look at the labels of the graph to truly be able to understand it. The bottom is weeks, the top is savings. By the way, it's the same thing as when you write it up and down. That means we do savings, or dollars, per week. The x-axis is going to be on the bottom, the y-axis is going to be on the top. So dollars per week. Well, what that's telling you is, the first point is telling you, hey, if she saves for 0 weeks, guess what? She gets $0 of savings. That's also telling you that it's proportional. If a graph is in a straight line, going in a positive direction, left to right, and hits the origin, 0, 0, it is proportional. And so that is a big key to the fact that it is proportional. Okay? Doesn't prove it's proportional by itself. We also have to know it's linear and that it goes in a positive direction. But now I go to 110. 110 is a special point also. That's the point right here. The point 1 on the x, 10 on the y. And why specifically is that one important? Because it's for 1. In fact, anytime that you have a proportional relationship and the first number is 1, the back number is going to be your constant of proportionality, your unit rate, your rate of change, that constant rate of change. We have a whole bunch of different names we name it. In fact, on a graph we call it the slope, which I like to refer to as the helicopter. Remember, plotted these points as an airplane, x and y. We use the slope. We use a slope, which looks more like a fraction, as the helicopter. So watch, to go from this point to the next point on the graph, I go up 10, and then I take off horizontally 1. Up 10, right 1. Up 10, right 1. That's our slope, our constant proportionality, our unit rate. And so since this starts with 1, that back number is our unit rate. our constant of proportionality. And so we'll go to number 3. How can you find the unit rate on a graph that goes through the origin? How can you find the unit rate, how much for 1, on a graph that goes through the origin? Well, I just gave you one way. If you happen to see that it goes through the origin in a straight line and the first number of one of the points is 1, there's one way to find your unit rate. It's going to be right there. Another way is you can count it with the helicopter. You can count up how many it's going up and put that over how many it's going over. That's called rise over run. That's called slope. That's called, we have a lot of different names for it, constant of proportionality. My goodness, that's a lot of names. And we have constant rate of change. And there's actually one more, which we call it the constant of variation, but I'm not going to teach that one as much. So constant rate of change, constant proportionality, the helicopter, the rise over the run, which is the slope. So we can find it from that point, or we could simply count it. So let me go back to this one. Any 2 points. So this time I'm going to go from that point to that point. If I go and count it, the rise, it goes up 10, 20, up 20, but then it goes right 2. And if you simplify 20 over 2, oops, can't see what I'm writing there, sorry. If you simplify 20 over 2, you're going to get 10, because that is the unit rate. 20 for 2, but 10 for 1. 10 for 1.